Now this question here brings in working with scientific notation for us. So that's this part here, the 6.6 times 10 to the negative 24. So that's scientific notation, so writing large or small numbers, in this case a small number, in a much more manageable manner. If we were to write this number out, we'd get 0.2300664. So, something we want to kind of whittle down and make easier for us to do. So we're told the mass of a helium atom, we're told a flask contains 300 grams of it, then we want to know how many helium atoms there are, and we want to give our answer again in scientific notation, but it gives us rounding this time of 3 significant figures. So a couple of steps there and a couple of points we have to take into account. Now, what we have in this question is we have the total, the 300 grams. We know what one of them is, so we want to divide that 300 grams amongst all of them in order to be able to get our solution. So in order to do this, I've got to take the 300 grams and divide it by the mass of 1 gram to figure out how many of those 1 grams are in it. So I'm going to do 300 divided by the 6.64 times 10 to the negative 24. Now that's a heck of a calculation to do. Trying to do that in your head is virtually impossible. So again, lucky it's a calculator paper. We can just hammer it into the calculator and get away with it from there. Couple of things to be aware of though. Just watch how you put it into the calculator. You'll notice I've put brackets around the 6.64 times 10 to the negative 24. If you're entering this whole thing as a one calculation in your calculator, make sure to include those. Because if you don't, you just enter 300 divided by 6.64 times 10 to the negative 24, there is a possibility your calculator may make an error when it does its calculation. So please just watch how you enter it in at this stage. If we enter that into the calculator and we hit equals, what we'll do is we'll get an answer 4.518, and then it'll be times 10 to the power of 25. Now your calculator may write it out without scientific notation. The majority of them won't. Because it'll be such a big number, your calculator will write out the answer in scientific notation. Now there will be numbers beyond the 4.518 on the screen. However, I'm only going to 4.518 because the question asks for it to 3 significant figures. And in order to do 3 significant figures, I only need those 4 digits. Because remember, 3 significant figures, we cut it off after the third non-zero digit from the first non-zero one. So in this case, we cut it off there. Now our normal rules of rounding apply. So if it's 5 or above, it goes up. The previous number goes up by 1. If it's 4 to 0, previous number stays. So an 8 after the cut. So that one is going to go up to 2, and I'm going to end up with 4.52. I'm then going to have times 10 to the power of 25, and that is how many helium atoms are in the flask. So just a couple. Question like this, fairly straightforward set of steps and a fairly straightforward 3 marks involved. First mark for knowing what calculation to do, second mark for doing the calculation and getting the unrounded answer, third and final mark for stating the rounded answer, so getting that final bit right there. So follow those steps and get those 3 parts together, and you should nail a question like this. Now the hardest part about this one, to be honest with you, is working with the scientific notation. The actual maths behind it, knowing to divide the 300 by the mass of 1 atom, is actually fairly straightforward in maths that we should instinctively know anyway. It's just that number that happens to be the thing that comes into play and that we have to work with, that ups the ante, if you like. So be wary of those steps, be wary of those little tweaks, little bits and little errors that could come into play. Follow this question through and use your natural mathematical ability to get there. And if you do that, you should find the answer to this one, no problem. Solving this one, no problem. Easy peasy, lemon squeezy.